This is my new to me Emotiva DAC, digital to analog converter, for taking digital audio sources and turning them into analog on your standard RCA leads that can be amplified and drive a speaker. Can't drive a speaker with ones and zeros. Well, can't ordinarily. I think you can get amplifiers that are directly controlled by a digital stream, but I don't have one. This is an excellent example of audio engineering. The thing and industrial design. This is all aluminium. It has lovely ports on the back. It has 2 optical inputs, 2 coaxial inputs, a 3-pin industrial commercial type input, and it also has both RCA barrel style and XLR audio outputs. The XLR outputs are really good in commercial environments. The cables are fantastic at rejecting noise. In a home environment though, I don't think there's any need for them whatsoever. So the front of the unit is also quite something, and this brand I think is known for producing stuff of a very high quality, but with a minimum amount of oogada boogada. And in my view, high quality audio gear is about good engineering and not about subjective listening tests, particularly subjective listening tests that aren't double blind. I have no time really for someone's elaborate dizzying descriptions of audio and how it sounds and how it's better than something else. High fidelity stuff will pass the signal in as close to the original form as it could possibly be, and in my view that's the end of that. This unit is built to a specification, which means that even if human hearing were to evolve to have double the fidelity that it currently does, I would be startled if anybody could pick this DAC from any other DAC that was properly built. Honestly, these days a $10 DAC the size of a stick of gum that plugs directly into a USB port produces an excellent result. Here in the 21st century, audio frequency conversion from the digital to the analog domain is just not a state-of-the-art proposition. That said, this thing is lovely. Nice remote control. Gives me some volume control as well, and the volume control is done in the analog domain. It doesn't reduce the number of bits in the signal anywhere, so I get the full fidelity of even the 16-bit signals. And I'm looking forward to using it. I have an awful lot of miscellany, audio miscellany here in my workshop, and I'm always short of inputs, and this is a part of the solution to that problem. So let's have a look inside. I'll get the screws out now, and we can have a little look. It is beautiful. Wow, it is beautiful. So what have they done here? The mains input part of the enclosure has this metal divider on it. Any noise from diodes turning AC into DC is fairly well trapped inside this space, which is lovely. They're nice, you probably can't see them, nice plastic inserts there to stop the cables wearing on any sharp edge that might be established. Lovely piece of work. And so this block here takes the incoming mains, passes it to this transformer, gets it back. They're all rectifier diodes. I mean, they only have to be small. We're not dealing with a lot of power here. This is not a power amplifier of any power. It's just for headphones and line level signals. The bridge rectifiers are in here for the different windings on the transformer to produce the different voltage rails. that then come over to this part here. This fellow, I think, well, this just looks like, I'm not saying, I don't know, but I think it's a switch mode power supply, which switch mode power supplies are great, but they are more difficult to engineer, and they're more difficult to make in a way such that there is no high frequency noise on the outputs of it. I think really though that's more of a concern of audiophiles, and a high quality switch mode supply over here, especially one that's then subject to linear regulation, would have been just fine. But this is lovely, and a power supply like this will last with basic maintenance, perhaps for tired electrolytic caps, will last indefinitely. It's a lovely design. There's some ribbon cables. There's this one that goes over here to the front panel, and then this ribbon cable here appears to take the power over to this board. Over on that board there is a digital to analog converter chip. I think it's a Crystal one, Crystal brand, CS something 24-bit, 192 I think kilohertz sample rate, just completely over the top, which is great. I mean, one thing you can be sure about with a unit like this is that to any extent that the audio, one thing I can be sure about with something like this, I should say, is to any extent that the audio that I'm listening to doesn't sound great, it's not this thing's fault. It's beautifully done. Bunch of linear regulators through here, and then up to this end I think they're transistors for the headphone amplifier, and the headphone amplifier does sound wonderful. My favourite headphone amplifier currently, as unromantic as it is, I mean, we don't, you know, we're interested in engineering here, is powered by an IC, an operational amplifier that was developed for ADSL modems, and an amplifier that can drive those sorts of frequencies that are involved in modem data down up to, say, a couple of kilometers of copper cable. A chip that can do that in a way that allows for substantial data throughput. A chip like that can drive headphones without even trying, and it's a beautiful sounding amplifier. It's not discrete components and so on, but with 21st century engineering it just doesn't have to be. The only review I've ever seen of that chip, which of course comes with a reference design, just like this does from the manufacturer, the only review I've ever seen of that chip was by a fellow whose instrumentation was not able to measure noise because it was below what his instrumentation could measure. And that's unsurprising, and they drive headphones wonderfully. They drive headphones in their sleep. But this is great. You know, this is some beautiful engineering. It's sort of, in some ways, it's an approach to building this stuff which has got a component of tradition to it, in addition to good modern engineering. So I'm looking forward to using this. I'm looking forward to having a remote control to select between various digital sources, including things like a DVD player, a Laserdisc player, a Raspberry Pi that's connected to my network, and so on and so on and so on. It will be a great accompaniment to those devices, and will give me a headphone amplifier to use as well, which I can both use with headphones or can actually use to drive an amplifier or other things in the course of testing some of the audio gear that I build here. So that's fantastic. Not much more to add other than to note this ferrite, I think it is, clipped onto the headphone lead. I think that's absolutely fine. It would be very effective at reducing any really high frequency noise on the amplifier leads that might come from the headphones into the unit or vice versa. And sure, it will attenuate high frequencies to some degree. I'd be stunned if they were frequencies the headphones could reproduce in any case, And if the headphones could reproduce them, they'd probably only be heard by my pets. Anyway, that is my digital to analog converter. I'm very happy to have it.